Simplify 3a squared over 2b all over 15ab over 4b cubed. This is a complex fraction, or a complex rational expression, which means it is basically a fraction with fractions inside of it. When simplifying complex fractions, we essentially want to turn them into regular fractions, where the numerator and denominator are just polynomials, where there are no longer fractions inside of the main fraction. There's two different methods that we can use, and the method that we use depends on the form that the complex fraction is in. This one is the simpler form. In this case, the numerator is just a single fraction and the denominator is just a single fraction. There aren't any additions or subtractions in the numerator or denominator. So in a situation like this, effectively, we know that a fraction bar denotes division. So this problem is one fraction divided by another fraction. And I'm going to actually write that out for us. This is effectively 3a squared over 2b divided by 15ab over 4b cubed. And writing it like this might make our path forward more clear because we know how to divide one fraction by another fraction. We can turn it into a multiplication problem by taking the reciprocal of the second fraction. So we can change the division to a multiplication, and we can change that second fraction into 4b cubed over 15ab. We have already done this before. We have done fraction division. This is just a little bit more complicated because there are variables inside. But once we change it to a multiplication, it's pretty easy to move forward. We multiply fractions straight across. So in the numerators, 3 times 4 gives us 12. And then we also have the a squared and b cubed. In the denominators, 2 times 15 is 30. And we also have an a down there. And if we multiply the b's, b times b is b squared. So the denominator becomes 30ab squared. And then we can simplify from here. 12/30 reduces. Both 12 and 30 are divisible by 6. So when we reduce by 6, we end up with 2 over 5. If we look at the a's, one of the a's in the top will cancel with the a in the bottom. That leaves us with a single a in the top. And the same thing happens with the b's. We've got one b left over in the top because there's a b squared that cancels in the top and bottom. Another way to think about this is that when we have a quotient of 2 powers of the same base, we subtract the exponents. For the a's, this a is actually a to the first. So a squared over a to the first, we subtract the exponents, and 2 minus 1 is 1. So we're left with that a to the first. And the same thing happens with the b's. We subtract the exponents. 3 minus 2 is 1, and b to the first is just b. Either way, we end up with our answer of 2ab over 5. Now, there was one more thing that we can do. When we are multiplying fractions, we know that we multiply them straight across, but we can also cross-cancel. Some students prefer this. Sometimes I think it's easier, but sometimes it just makes things a little bit messier. So I'm going to redo this problem, at least the second half of it, with cross-canceling. Now, if we look to see what reduces or cancels, we notice that there's a 3 and a 15, and those are both divisible by 3. So if we reduce them by 3, that leaves us with 1 on the top and 5 on the bottom. We also notice that the 2 and the 4 are both divisible by 2. So if we reduce those by 2, 4 divided by 2 is 2. 2 divided by 2 is 1. If we look at the a's, we've got an a squared on the top and an a in the bottom. We can cancel out one of the factors of a's in each of those. On the top, the a squared just becomes an a, and the bottom, a divided by a is 1. The a effectively cancels out. And then with the b's, we've got that b cubed on the top, and we've got 2 factors of b in the bottom. So we can cancel out those 2 b's in the bottom with 2 of the b's in the top, And if we take b cubed and get rid of a b squared, we're left with b. So here we've canceled everything we can. Now we just need to multiply 1a times 2b is 2ab on the top, and we're just left with 5 on the bottom. Some people might think that this is easier, and in effect it might be, but one of the biggest problems is that it's very easy to miss something when we're canceling things out. There might be something that doesn't reduce or doesn't get crossed out, but we might forget about it because it's not down below with the other things. So it's just very easy to miss something when we're doing cross cancellation. So you might find in many circumstances it's easier to just multiply across, and then you can reduce things without having a whole bunch of marks all over the place.